Right, Ram. So last class we were discussing, right, equilibrium, right? In equilibrium, the reactant is converting into products and products are converting into reactants. The reaction takes place in both the direction, right? The reversible reaction. In case of irreversible reaction, reactant is converting into product, but product cannot be converting into reactant. This takes place in which container? Closed container. This is in the open container, right? And in case of equilibrium can be attained in all the directions. Means from reactant to product or product to reactant. After attaining the equilibrium, there is no change in the measurable properties like color, pressure, temperature, volume, density, mass, moles or anything. So there is no change after attaining the equilibrium. So and the role of catalyst here. So catalyst means what? So catalyst, after attaining the equilibrium, there is no role of catalyst. Before, so the catalyst will help to attain the equilibrium in a easy mode. Equilibrium తొందరగా అటైన్ అవ్వడానికి మాత్రం పనిచేస్తుంది. ఒకసారి ఈక్విలిబ్రియం అటైన్ అయిన తర్వాత there is no change, means there is no use of the catalyst, right? I told you 4 properties of the equilibrium, and according to law of mass action, what is law of mass action? AA, for example, PB gives rise to TC plus DD, right? So rate is directly proportional to concentration of A power A and B power B, whatever the coefficients, right, are there stoichiometric coefficients, we have to write like this. So this is RF, nana, rate of forward reaction, this is rate of backward reaction. So in this case, rate is equals to KF, right, equilibrium constant for the forward reaction, right, A power A and B power B. This is for reactants. Always the law of mass action will speak about the reactants. This is the reactants. For the backward, these are the reactants, right? So from backward, if you are writing, this is equation number 1. So this is our rate of forward reaction. The rate of backward reaction, what nana? Rate is directly proportional to now C power C, D power D. So rate is equals to KB, backward reaction C power C and D power D. So at equilibrium, what exactly happens? At equilibrium, rate of forward reaction is equals to rate of backward. So both rates are equal, equation 1 and equation 2. So KF, A power A and B power B is equals to KB, C power C and D power D. So here is KF by KB. KF is here, KB I'm just, right, is equals to what, nana? C power C, D power D by A power A, B power B. So KF by KB, generally we could say this is KC if you are taking the concentration. Concentration means what, right? This is active mass, C power C, D power D by A power A, B power B. Write it on this. So the last class I told you 7 properties, nana. What are those 7 properties? Equilibrium is in the dynamic in nature. Next, equilibrium involving the gas is established in the closed, of course. So equilibrium state unaffected by the catalyst in presence, right, but attained faster or slower depending upon the catalyst type. System moves in equilibrium spontaneously. So I told you they'll ask the questions, which of the following statement is true or false regarding the equilibrium. I think I explained in the last class. The rate of forward reaction is equals to rate of backward reaction. So at equilibrium, what exactly happens, nana? right? And the concentration of reactants and products becomes constant. At equilibrium can be achieved from the both directions. At equilibrium, free energy change delta G is equals to 0, right? N2 plus 3H2 write for this equation. Case N2 plus 3H2 gives rise to 2NH3. So Kc is equals to always for when the equilibrium, whenever we are writing, first we need to write the product by reactant. Write it down, NH3 power 2 by N2 gas and H2 power 3. Write it down. Now I told you this is the important 5-star point. No? H1, Kf and Kb depends on only temperature. Kf and Kp depends only on temperature. 5-star point. So when we will write the Kp means at least one gas should be present, then only we will write the Kp. At least. So write it down, at least one gas should be present. At least one gas should be present. Right. For example, same AA plus BB gives rise to CC plus DD. Right. Kp is equals to partial pressures. P C power C into P partial pressures T power D by P A power A into P power write it down. So here is P means partial pressure in terms of partial pressure. Kp and Kc. So this is Kc already we discussed. Kp right now we wrote. So relationship between Kp and Kc. So in case of if your board exams, in case of in your board exams, they'll ask the derivation. Otherwise, directly we know the difference. So we know P is equals to CRT means partial pressure of the gas concentration. PV is equals to nRT. Nothing but T, nothing but concentration. Concentration nothing but what? See, concentration nothing but N by V. PV is equals to nRT like that. So P is equals to N by V RT. So PV is equals to nRT. P is equals to N by V RT. P is equals to, we can say N by V nothing but CRT we wrote. P is equals to CRT, just write it down this. P means partial pressure, C means concentration of the gas, universal gas constant, or T means absolute temperature. So we know Kc value, right? T, concentration nothing but P by RT. P is equals to RT, right? TRT. Concentration is equals to P by RT. So in case of Kc, C place can we write P by RT? Right? Pc, PD by RT, same. Just substitute the C value. C ఇక్కడ ఏంటంటే మనకు P is equals to TRT అని రాసాం కదా. Concentration is equals to P by RT. RT power C and PD power D by RT power D. PA by A, RT power A like the same. Now we can extract this one. Kc is equals to, right? Pc PC PD PA PB into RT power A plus B minus C plus D. Delta Ng, number of moles of gaseous products minus number of moles of gaseous reactants. So Kp is equals to Kc power RT power delta N. This is important for us. ఇక్కడ మైనస్ ఉంది కదా, డెల్టా మైనస్ జీని మనం ప్లస్లోకి రాసాం కాబట్టి Kp is equals to, right, Kc power RT power delta N. Kp is equals to Kc into RT power delta N, Ng. What is Ng? Number of moles of gaseous products minus number of moles of gaseous reactant. In this case, T, what is T? Temperature, temperature we need to take in Kelvin, okay? R value 0.08. 0.08, or generally we can take 1 by 12. So delta Ng means what? the sum of stoichiometric coefficients of gaseous products minus the sum of stoichiometric coefficients of gaseous reactants. In this case, 2 minus 4 minus 2. Write it down. Delta Ng, the sum of stoichiometric coefficients. Stoichiometric coefficients means what? These are 2, 3, 1. The sum of stoichiometric coefficients of gaseous products minus the sum of stoichiometric coefficients of gaseous reactant. So units, Nana. So here is Kc and Kp units. For example, N2 plus 3H2 gives rise to 2NH3. What are the units for Kc in this case? What are the units for Kc? What are the units for Kp? And what is the relationship between Kc and Kp in this case? What is relation? What is the relationship between Kp and Kc for this particular equation? Units for Kc. What are the units? Right, here is concentration of NH3, right, power 2 by N2 and H2 power 3. Concentration means I told you what is concentration, mole per liter, right? So here is we can write mole per liter square by mole per liter into mole per liter cube. Otherwise, already we know what is delta Ng value, delta N value. So 2 minus 4 minus 2. Otherwise, we can write mole per liter delta N. Mole per liter delta N, Kc units now. Kp units, atmosphere delta N. Ng, write it down. So delta N case minus 2. So write it down. What we will get? Mole minus 2 liter square. If delta Ng is 0, then Kp is equals to Kc. Delta Ng equals to 0. Kp is equals to Kc. So in this case, Nana, Kp is equals to Kc into RT power minus 2. So now, which one is, what is the relationship, bro? So n number of times they are asking this question. Option A, Kp greater than Kc. Easy question. Kp less than Kc. Come on, let me know. Kp less than Kc. So this value, Kc value is more here, right? That is the reason negative, when is negative is coming. So Kp less than Kc. Write it down. When delta Ng greater than 0, write it down this one. And delta Ng equals to 0, Kp is equals to Kc. If delta Ng, right, greater than 0, what happens? Kp greater than Kc. If delta Ng less than 0, Kp less than Kc. So don't by heart this, try to understand that, okay? For example, H2 plus I2 gives rise to 2HN. Imagine all are gases. All are gases. This is gas, gas, gas. Now, what is the relationship between Kp and Kc? Write the question. What is the relationship between Kp and Kc? Kp is equals to Kc. Kp greater than Kc. Kp less than Kc, don't know. What is the relationship between, question, what is the question? What is the relationship between Kp and Kc? What is the relationship between Kp and Kc? Option A. In this case, what exactly happened? Delta Ng is equals to 0, right? Kp is equals to Kc RT power delta N. Delta N is equals to, in this case, 0 because 2 minus 2. Number of moles of gas, stoichiometric coefficients of gases, products minus gaseous reactants. 2 minus 2, it is 2 minus, it is 1 plus 1. This is 1, this is 1, 1 plus 1, nothing but 0. So, answer will be Kp is equals to Kc. 2 NO2 gives rise to N2O4 gas. Same, what is the relationship between Kp and Kc? Kp is equals to Kc, Kp greater than Kc, Kp less than Kc, and D don't know. Minus 1, right? 1 minus 2, minus 1, right? Delta Ng is what, Nana? Less than 0. Less than 1, minus 1 means less than 0. Less than 0 means option CaCO3 gives rise to KO plus CO2. Is solid. Same question. Kp is equals to, what is the relationship between Kp and Kc? So in this case, what is Kc? Kc is equals to concentration of CO2. Because solids we can't take. Okay. Kp is equals to, how can we write? P CO2. 1 minus 0. So delta N greater than 0. So what is the answer? Delta N is equals to 1, right? When greater than 1. So answer will be, for example, H2O liquid gives rise to H2O gas. H2O gas. Now let me know. What is the Kc value? What is Kc? Liquids also we will take constant. Kc is equals to concentration of H2O. Kp is equals to P H2O. So here is also delta Ng is equals to 1 minus 0 because in case of liquids we can't take nano. Right? So 1 minus 1. 1 means greater than 0. Greater than 0 means Kp greater than Kc. Next one more important. This is very important. CH3COOH, the liquid. CH3COOH plus C2H5OH is a liquid. Gives rise to CH3COO. So H5 is liquid plus it is also liquid. Now in this case, can we define? Can we define Kc and Kp? So if all are liquids right? We can define Kc, right? COOH T2H5OH. What is delta N? Delta N 2 minus 2 0. If one gas is there, then only we can define the Kp. Kp is not defined. Kp is not defined because here is no gas. 2NH3 plus CO2 gives rise to NH2 COO NH4. This is gas, imagine. This gas is solid. Now write define Kp, Kc. First write the Kc value, Kp and relationship between Kc and Kp. Relationship between Kc and Kp, just write it down. 1 by, because solid we can't take, by concentration of NH3 power 2 concentration of CO2. Kp is equals also 1 by P NH3 power 2 P CO2 nana. P CO2. So what is the delta N value nana in this case? Delta Ng 0 minus gaseous products are solid, right? Minus 3. Kp is less than Kc. Kp is less than Kc. Right now. So before going to the equilibrium constant, so we write a question here, right? For example, this is very important. Right? H2 plus I2 gives rise to 2HA. Imagine all are gases. Okay. So here is the question which I am giving you. So how we need to calculate or solve the numericals. So first we need to know these fundamentals. For initial moles, for example, initial moles, I'm taking this is A, this is B nana. Right? At time t is equals to 0, means the reaction is not yet started. At time t is equals to 0. Time t is equals to 0, initial. So then after time equilibrium, T at equilibrium, some x moles of A is converting into B. So means A minus x, B minus x, this is 2x. We are taking this is in the container, V liters of container. So V liters of container. A moles of H2, write it down, write a question. A moles of H2 and B moles of I2 and B moles of I2 are taken in a closed container of volume V, at temperature T. If x moles of H2 are dissociated at equilibrium, write the expression or derive the expression Kp and Kc for this reaction. So this is very important to solve the numericals, because in total in chemistry the equilibrium questions somewhat complicated, chemical equilibrium as well as ionic equilibrium. So particularly to solve those questions, this is a fundamental thing. So initially I am just taking A moles V moles. Reaction at time t is equals to 0, reaction not yet started. So we are taking in V liters of container, right? Concentration. What is concentration? So for this Kc, how we can define? Kc is equals, how can we define? Hi whole square by H2 into I2. So here is square brackets. I told you law of, right, active mass. Active mass, nothing but concentration. Concentration, nothing but what? N by V. What is N? Number of moles. V means volume. Volume, I told you in the question, V liters, right? These are the number of moles at equilibrium, right? Number of moles. Concentration, how can we write? Hello. Yes, I'll write here. Concentration. Number of moles, A minus X by V. Number of moles by concentration. What? Number of moles by V liter. In this case, B minus X by V. This is 2X by V. Kc is equals to I told you Hi whole square by H2 power and I2. So just substitute the values. Kc is equals to Hi in place, what is there? Right? 2x by V. Right? 2x by V whole square by, it is A minus X by V to B minus X by V. So 2x square by A minus X to B minus X. So V square, V cancel total. This is Kc. 4x square minus A minus X minus B minus X. That is the Kc value. How they'll ask the question here? For example, 5 moles of H2, 10 moles of I2 are taken in a 2 liter container, something else. From 5 moles of A, 5 moles of B, right, dissociated. So calculate the Kc value. So in case of A and B and X values, they'll give just what we need to do. We need to substitute this type of equation. So write it down. Kc means this is the Kc equation, but original Kc, this we need to derive like this. Concentration, right? Write it down now. So for Kp, we will define for this sake. This is very important, and each and every case, whenever it is coming, so we need to derive like this only. So H2 plus I2 H2 2Hi. Imagine all are gases, right? All are gases. So same initial moles which I am giving, A, B, 0, time t is equal to 0. So then after equilibrium, A minus X, B minus X, this is 2X. T equilibrium. These are number of moles at equilibrium. We need to define for Kp. Kp is equals to what? P Hi whole square by P partial pressure into P I2. What is P here means partial pressure. What is partial pressure? One of the important thing. Partial pressure. PP, partial pressure I am writing. Mole fraction into mole fraction into P total. Total pressure. Total pressure. Total pressure. Total pressure. Okay? Hello. How can we calculate this total pressure, Nana? How can we calculate this total pressure? PEV is equals to nRT. P is equals to nRT by V. N means what? Number of moles, total number of moles. It is how many total number of moles at equilibrium? Total number of moles. So here is A minus X plus B minus X plus 2X. X, this 2X will be cancelled. A plus B. So P is equals to A plus B. RT by B. That is for total pressure. So mole fraction means what? Here mole fraction, write it down. Mole fraction. What is mole fraction? Number of moles by total number of moles. It is number of moles A minus X by total number of moles A plus B. B minus X, total number of moles A plus B. There is 2X by A plus B. This is mole fraction. Partial pressure is equal to, I told you, mole fraction into P total. This partial pressure equals to A mole fraction A minus X by A plus B into P total. This is for H2. This is for I2. B minus X by A plus B into P total. For this one, 2HI, 2X by A plus B into P total over 2. So this partial pressures we need to keep on the particular equation. In this case now, Kp is equals to HI 2x by A plus B into P total whole square by A minus X plus A plus B to P total B minus X A plus B to P total. Kp I am just writing here. Kp is equals to లేదురా వాల్యూస్ అనేది తీసుకొచ్చి దీంట్లో పెట్టేసాం. సో Kp is equals to A plus B all will be get cancelled and because in this case same 2x square A minus X to B minus X. I already told you delta Ng is equals to 0. In this case Kp is equals to Kc. So we need to first cross check why I explained the total mechanism, because to how to derive. Okay, but Kc is equals to what we got, same Kp also same, because Kp is equals to Kc when delta n is equals to 0. But whenever we are solving the numericals, right, so we should understand what exactly mole fraction, what is mole fraction, what is total pressure, what is partial pressure. So partial pressure is equals to mole fraction into P total. P total means PV is equals to nRT. So from this we need to derive. So this is, so directly they won't ask to derive this one. This is to understand how to solve a numerical, right? So write it down. When delta n is equals to 0, that cases it's easy for us to calculate the Kp value also. N2 plus 3H2 gives rise to 2NH3. So initial moles take same A, B dash, A minus X, B minus 3 extra. How many number of moles is there that we have to take? So then here is 2x. So Kc value I am just calculating for you guys. This is number of moles equilibrium, right? Concentration means what? I'm taking n number of a minus x by v, v minus 3x by v, 2x by v. So initial moles, this is concentration, moles at equilibrium. Kc is equals to NH3 concentration or square by N2, right? H2 power 3. So now put the values in this case. NH3 means what? 2x by v square by a minus x by v, v minus 3x by v whole cube. Solve it. Kc is equals to 2x square means 4x square by a minus x to b minus 3x square into b square into b square. This is Kc. How can we write the Kp? Kp homework చేసుకొని వచ్చేసండి. కేసీ కేపీ పైన కొన్ని క్వశ్చన్స్ చేద్దాం రేపు కొన్ని క్వశ్చన్స్ చేద్దాం కేసీ కేపీ పైన. సో వాళ్ళ తర్వాత థర్మోడైనమిక్స్ ఈక్వేషన్స్, చార్ట్లేర్ ప్రిన్సిపల్. సో నెక్స్ట్ క్లాస్లో ఆల్మోస్ట్ ఐ ట్రై టు కంప్లీట్ సో దిస్ ఈక్విలిబ్రియం పార్ట్. బట్ మేజర్ అండ్ ఇక్కడ డిగ్రీ ఆఫ్ డిసోసియేషన్ అని ఒక చిన్న పార్ట్ ఉంటుందా, సో దట్ ఆల్సో ఐ డిస్కస్ దట్ బికాస్ లాట్ ఆఫ్ పీపుల్ ఆర్ కన్ఫ్యూజింగ్ డిగ్రీ ఆఫ్ డిసోసియేషన్ దిస్ కేసెస్. ఫస్ట్ ఏంటంటే మీరు కేసీ ఏంటి, కేపీ అంటే ఏంటి, యూనిట్స్ ఏంటి, ఎలా వాటి రిలేషన్ ఎలా చేస్తాం, ఏ టైంలో ఏవి తీసుకుంటాం, అసలు ఈక్విలిబ్రియం యొక్క క్యారెక్టరిస్టిక్స్ ఏంటి, సో దోస్ థింగ్స్ పైన కాన్సన్ట్రేట్ చేయండి. అండ్ ఇవి ఈక్విలిబ్రియం కాన్స్టెంట్ ఈక్విలిబ్రియం కాన్స్టెంట్ ఒకవేళ ఇప్పుడు ఈక్విలిబ్రియం ఏ ప్లస్ బి గివ్స్ రైస్ టు సి నాను కేసీ ఈజ్ ఈక్వల్స్ టు కే అనుకుంటే ఇదే ఈక్వేషన్ మనం రివర్స్ చేసాం అనుకోండి, కే ఈజ్ ఈక్వల్స్ టు ఏ ప్లస్ బి అన్నప్పుడు ఈక్విలిబ్రియం కాన్స్టెంట్ కూడా రివర్స్ అవుతుంది. ద ఫస్ట్ పాయింట్ నెంబర్ 1. ఇఫ్ ద రియాక్షన్ ఈజ్ రివర్స్డ్ ద ఈక్విలిబ్రియం కాన్స్టెంట్ right is reciprocated, right? Write it down, this one, k value. This is also one of the important examiners favorite. దీన్ని మల్టిప్లై చేసినప్పుడు ఏం చేస్తాము, డివైడ్ చేసినప్పుడు ఏం చేస్తాము, యాడ్ చేసినప్పుడు ఏం చేస్తాం, దోస్ థింగ్స్. ఫస్ట్ ఏంటంటే ఒక ఈక్వేషన్ని రివర్స్ చేసినప్పుడు రైట్ కేసీ వాల్యూ ఏమవుతుందంటే ఇది రెసిప్రోకేట్ అవుతుంది, రైట్? కేసీకే అయితే దానికి ఆపోజిట్ ఏమవుతుంది 1/k. రైట్ ఇట్ డౌన్. నెక్స్ట్ సెకండ్ వన్, ఇఫ్ ద రియాక్షన్స్ ఆర్ మల్టిప్లైడ్ విత్ సమ్ ఎనీథింగ్, రైట్, మల్టిప్లైడ్ బై ద n ఫ్యాక్టర్, రైట్, ఐదర్ 2 ఆర్ ఎనీథింగ్. సో ఏదైతే మల్టిప్లై చేస్తామో దాని కేకి పవర్ n వస్తుందిరా. అంటే ఫర్ ఎగ్జాంపుల్ ఏ ప్లస్ బి గివ్స్ రైస్ టు సి ఈక్వేషన్ ఉంది, దీన్ని మనం ఆఫ్ తోటి మల్టిప్లై ఆఫ్ చేస్తాం ఈక్వేషన్ మొత్తం. ఆఫ్ చేస్తే ఏమైంది, ఆఫ్ ఏ ఆఫ్ బి ఆఫ్ అయింది కదా, సో కే ఏమైంది, కే కూడా ఆఫ్ అవుతుంది. ఫర్ ఎగ్జాంపుల్ దీన్ని 2తో మల్టిప్లై చేసాం అనుకోండి, కే పవర్ 2 అవుతుంది. 3తో మల్టిప్లై చేసాం అనుకోండి, కే పవర్ 3. అర్థమవుతుందా? సో ఏదైనా మల్టిప్లై చేస్తే దాని పవర్ వెళ్ళిపోతుందిరా. సో రైట్ ఇట్ డౌన్. ఇఫ్ ఏ రియాక్షన్ ఇస్ మల్టిప్లైడ్ విత్ ద n ఫ్యాక్టర్ ద వాల్యూ ఆఫ్ ఈక్విలిబ్రియం కాన్స్టెంట్ బికమ్స్ k పవర్ n. k పవర్ n. a ప్లస్ బి గివ్స్ రైస్ టు సి, వీలైతే ఇట్లా కూడా రాసుకుంటారు, 2a 2b gives rise, right? Kc is equals to k power 2. అర్థమైంది కదా? 3 చేస్తే 3 అవుతుంది, 4 చేస్తే 4 అవుతుంది. సో ఇది ఇంకా ఇంపార్టెంట్. మనం ఇప్పుడు 2 ఈక్వేషన్స్ని యాడ్ చేసినప్పుడు ఆ రెండింటిని ఏం చేయాలంటే రైట్ మల్టిప్లై చేయాలి. ఫర్ ఎగ్జాంపుల్ ఏ ప్లస్ బి గివ్స్ రైస్ టు సి, రైట్, సి గివ్స్ రైస్ టు దిస్ ఇస్ k1 k2 నాను, రైట్? సో రెండింటిని మనం యాడ్ చేస్తే రైట్ ఏమొస్తుంది మనకి, ఇలా వస్తుంది చూడండి. ఏ ప్లస్ బి ఇక్కడ రాస్తున్నాడు, ఏ ప్లస్ బి గివ్స్ రైస్ టు సి, ఇది ఎంత k1, నెక్స్ట్ నాన్న, సో ఇక్కడ ఏంటి సి గివ్స్ రైజ్ టు డి, ఇదేంటి K2, PC కెన్ క్యాన్సిల్ రా, A ప్లస్ B గివ్స్ రైజ్ టు D, ఈ వాల్యూ వస్తుంది మనకి. ఓకే, అప్పుడు ఈ రెండింటిని యాడ్ చేసాం కదా, అప్పుడు ఈ రెండింటిని ఏం చేయాలి, మల్టిప్లై చేయాలి. K1 ఇంటూ K2, యాడ్ చేయొద్దు. సో రెండు ఈక్వేషన్స్ని మనం యాడ్ చేసినప్పుడు ఈక్విలిబ్రియం కాన్స్టెంట్స్ని యాడ్ చేయొద్దు, మల్టిప్లై చేయాలా. వెరీ 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 ఇంపార్టెంట్, రైట్ ఇట్ డౌన్. మనం నార్మల్గా రెండింటిని యాడ్ చేసినప్పుడు ఈక్విలిబ్రియం కాన్స్టెంట్స్ కూడా యాడ్ చేస్తూ ఉంటాం. యాడ్ చేయొద్దు, ఏం చేయాలా, మల్టిప్లై చేయాలా. రైట్ ఇట్ డౌన్. ఇఫ్ వీ యాడ్ 2 or more equilibrium reactions, final equilibrium constant of product of individual constants into multiply చేయాలి, బట్ నాట్ యాడ్. సో మనం ఇక్కడ ఆప్షన్ ఏలో మనకి K1 ప్లస్ K2 అని కనిపిస్తుంది. ఆప్షన్ బిలో K1 ఇంటూ K2, ఏది K1 ఇంటూ K2, నాట్ K1 ప్లస్ K2. మరి ఇక్కడ యాడ్ చేసినాం కదా సార్, మరి ఈ రెండు ఈక్వేషన్స్ యాడ్ చేసినప్పుడు ఈక్విలిబ్రియం కాన్స్టెంట్స్ని యాడ్ చేయొద్దు. Equilibrium constant does not depend upon the concentration of reactants, presence of catalyst, right? Which direction the equilibrium is reached. It depends only on temperature and stoichiometric coefficient, right? This 5 points for the equilibrium constants. 5, then it's 7 points, 5 points, golden points, no? So there is a huge chance to ask the questions from these 5 points. Huge chance, huge నేను చెప్తున్నాను కదా, 5 స్టార్ పెట్టుకోండి. నేను ఎక్కడైతే 5 స్టార్ అంటున్నానో there is a huge chance.